Welcome to FMA 0146 Basic Mathematics. In this video, we are going to discuss Chapter 4.2 Determinant of Matrices. We are only going to concentrate on two sides, that is 2 times 2 and 3 times 3. Then we will discuss some of the properties of our determinants. Okay, so the determinant of the 2 by 2, so that means we have a 2 times 2. So, and then how to get the determinant? A multiplied D and then minus with the B multiplied C. Please don't interchange the sequence because the previously some of your senior, that is, they will be always reverse it. They will always be writing B multiplied C minus A multiplied AD. Is wrong, okay, because BC minus AD is going to produce different value. Okay, so that means we are going from the top to the right hand side, and then from the second is the minus from the top to our left hand side. Okay, now we're going to look at who is going to have the determinant. So determinant for a matrix order n times n. If you already see how we're going to write our determinant, actually just same as we are using the sign of absolute. Okay, they are standing in between the two bar. Okay, and if you see over here, the order must be m times n, so means that your A must be a square matrix. Okay, so and then you've been introduced, the first term over here is called minor. Okay, this one is not the piano minor major. This one is they just name is as a minor. The minor for AJ, okay, for any element, okay, inside your matrix is denoted by MIJ. Okay, is the determinant of the matrix after eliminating the ith row and the j column. Okay, so you no need to worry about this thing, but the thing is, this is the definition of our minor. Okay, so let's say you have a matrix and the element is A, B, C, D, E, F, G, H, I. Okay, so since over here they use the I, so I change it I, J, K. Okay, so I use the K over here. So if you want to know the minor, okay, minor for row 2, okay, row 2, and let's say is the third column. Okay, so minor for the row 2 third column is you eliminating this one, so means that I cover it with a line, row 2 third column. Okay, so I left out, I have 4 pieces element here, so then this one is A, B, G, H. So this is called the minor of my each element. Okay, and what is the core factor? Okay, so means that for each matrix, you're going to have 9 different minor by eliminating the different row. Okay, and then what is the something called core factor? The core factor for this element, let's say M23, is denoted by A. And then this one, no more calculation by looking at your matrix. What we only look at actually is our sign. Okay, so we are only we are going to calculate for the sign. So let's say you want to know my core factor for the 2, 3, A23. So what you're going to use? -1. Okay, so it's 2 plus 3. So it's 2 plus 3, and then you have your M23 back. Then -1 power of odd is a negative, so you are going to have a negative. So if you notice here, actually the sign are repeated, is interchange. So plus minus, and you go down also plus minus, and so on. Okay, so then after that we have the last one is how you want to find the determinant from the information before. Here is our determinant is, okay, this one by expanding along the ith or the j column. Okay, so means that if you have this column, okay, if you want to either you expanding by this row, if you're expanding by this row, so you need to find the cofactor of this row. If you want to expanding by the column, so you are expanding, finding all the cofactor for the column. Okay, so let us look at the first one. The minor of Aij is denoted by this one, is as just now already, we already mentioned. So let's say we look at our M11, is you're eliminating row 1, column 1, and then you left out is EFHI. If you want to know the M23, okay, so that means you eliminating row 2 and column 3, so you're going to have this as your minor. Okay, so then as I said at the previously, we have 9 different minor, so you need to eliminate each of them. Okay, so after that, what is the cofactor? Just now we are going to alternating the sign, so our plus minus, so always start with plus, the next is a minus, so our M11, it will become like this, that's all. Okay, and then let us look at the first example, A, 1, 2, 3, negative 1, 5, 7. So if I want to know M11, so I covered first row, first column. So I'm going to have my value for the first determinant, 5, 7, negative 2, 0. If I want to find 1, 2, so this is eliminating first row and then second column. And then this one is repeated, okay, for 1, 3. Then 2, 1, 2, 2, 2, 3, then 3, 1, 3, 2, 3, 3. If you see that is normally no people is jumping around, we will do systematically by go row by row, column by column. And then after that, how you want to get the this minor? So 5 times 0 is 0, minus 7 times negative 2 is 14. So this is the value of this determinant. Okay, so let us try another one. Let's say this one M22. 1 times 0 is 0, minus 3 times 4 is negative 12. So this is how you get the minor. So how are we going to find our cofactor? So remember, alternating the sign, plus, minus is plus. So this one is a plus, so the sign never changed. This one is a minus, so it's get a negative 6. And then this one nothing changed, so this one is a minus, so become 10. And then this one not changed because it's a plus, and this one is a minus, this one is a plus, so I already have my cofactor. Okay, so and then how to find our determinant? We are looking at this one is my original matrix, and then this is the cofactor we found it previously. Okay, now if you want to, you can do your determinant by expanding to either by column, by row, or the column. Doesn't matter which row, which column, but we always expanding by first row. This is only a habit, but if you see that is, let's say you see that is there is a 0 over here. If you want to expanding by the row 3, doesn't matter, because you know that 0 times anything is 0, so it's going to save you some work. Go ahead. Okay, but if not, normally we will be just expanding by our column, by our row, and then that means the row 1, A11 multiplied with my cofactor, and then C11, A12 multiplied C12, and then C13 multiplied C13. Or if you want, you can do, okay, so that is a 16. Or if not, you want to multiply by column also can. 1 multiplied 14, negative 1 multiplied with negative 6, and then 4 multiplied by your negative 1. They will give you the same answer. If you want to try, you can try row 3, column 2. It's up to you. Okay, and then we have another one shorter version to find the determinant of a matrix 3 times 3 by using diagonal expansion, just like our 2 times 2. But this one is only applicable for the 3 times 3. Okay, so what you need to do is, you want to find the determinant of this one. First thing, expand 2 column. You copy back the first 2 column, add at the back. Okay, after that, so you already become like this. Then you go by the diagonal way, just like just now. We have an AB minus CD, so we are going to the same thing. 1 multiplied 5 multiplied 0 is a 0, and then 2 multiplied 7 multiplied 4 is 56. And then the third one, 3 multiplied negative 1 negative 2 is a 6. Okay, and same thing just now, we find another way to this side. Okay, now we find the other 3. So what we're going to do is, just now we only have one line, AD minus BD. Now we have a 3 different line, but with the same thing. All the 3 sum of this, okay, actually this is a blue color minus the red. Okay, this is the 3 red. So then you sum of them. So actually is 0 plus 56 plus 6 is actually 62, minus 60 plus negative 14 minus plus 0 actually is 46. So you have a 16. So it's regardless using this way by the using the minor adjoint or using this one. But maybe you just saying that is why people spending time to do the minor way, because from that actually we are going to move on to our inverse. Okay, so this one, find the determinant of this question. So we will do this one during the class. Okay, so let's say fill in the blanks so the resulting statement is true. All questions refer to this matrix. So determinant. So what you need to do is you find the determinant of this one. The minor of M31. Okay, so we look at M3. This is 3 and this is 1. So we cancel here. We cancel here. So we're going to find the determinant of negative 1, negative 1, 1, 1. So actually this one multiplied is 1. Minus this one actually is 1 is 0. So the minor is this one is 0. Okay, and then the cofactor. Okay, so the cofactor for the C11. Okay, so I have a C11. So this one, the minor is 1, 0, negative 1, 2. So it's equals to 2 minus 0 is 2. But then the first one actually is a plus. So its answer is 2. Okay, and then for the C12, I already know that is the second one definitely will be a negative. So what I do, also same thing, determinant is 1, negative 1, negative 1, 2. So it's 2 minus 1 actually is 1, and then I have a sign from my cofactor, so this one is negative 1. Okay, so solving for x. Okay, so this is 2 times 2, so 3 times negative 5 minus x multiplied with negative 4x should be equals to 6. So I have a negative 15 plus 4x squared equals to 6. So my 4x squared equals to, move here, so it's 21. And then x squared is 21 over 4. And then my x is the square root of 21 over 4. And then plus minus. Okay. And then we can solving. Then it's still the determinant. But this one is 3 types, 3 by 3. So you have more work to do. And then this one you can use the extension version. Doesn't matter. Okay. Okay, so, and then we're going to discuss some of the properties of the determinant. First thing, your A must be a square matrix. So the determinant for the A and the A transpose will give you the same value. So it doesn't matter. Okay, if B is obtained by interchanging with any 2 rows of any columns, then your A determinant for A actually is negative B. Okay, what it means by this one? Okay, let's say I have my matrix A is A, B, C, D, E, F, G, H, I. And then my matrix B actually is D, E, F, A, B, C, G, H, I. So means that these two rows are changed compared to my A. If my A, the determinant for my A, let's say is 3, so the determinant of my B is negative 3 because these two rows already changed. Okay, and it happened to for our column also applicable the same thing. Okay, if any two rows or columns of matrix A are identical, so the determinant equals to 0. So for example, let's say my C is ABC, ABC, GHI. So these two rows are same, so that's mean my determinant actually is 0. Okay, and then if the matrix B is obtained by multiplying every element in the row or the column, so with a scalar, so the determinant of the B is Ka. So means that every element in the row or the column, so means is 2, 2, 2. Okay, so that's mean this one you're going to have 2 multiple 3 is 6. Okay, means it's only 1. Okay, let's say if you have another one is negative 3. Okay, every one is negative 3, so you need to multiply with negative 3 again. Okay, so because it said is n only the single. Okay, and then the E, if the matrix B is obtained by multiplying a scalar of one row of the matrix is added to another row of A, then B is equals to A. Okay, so means that is you have your B. Okay, so then is let's say F A, B, C. Then this one actually is A plus D, B plus E, C plus F, and G, H, I. So that's mean this is the meaning of this one. Okay, one row and then added to another row. Okay, and then the last one, if the matrix A has a row of the 0, okay, every element is 0, so your determinant is 0. That is the best of the world. Okay, so now look at example 4.9. Let's say they ask you to find, okay, this one. Okay, I don't spend time over here to find this one. Okay, let's say this value is A. Okay, so now because the question asks you to deduce, okay, so it means that they don't expect you to recalculate this value, this determinant. So what you only can see is you are comparing these two. The first row, same, but the second row, the third row, same. Only the second row are different. How do you get from this second row? The first element times 2, the second element times 2, this one times 2. So means that the second row of the new matrix, everything times 2. So that means this one is answer is 2A. The value of, let's say this one is A. So then this one is 2A. Okay. So, and then we look at this one. 126, no. Okay, this one is 216. So there is a possibility these two rows are already interchanged because the third column are these two columns is already interchanged. The third column are same. So when we already interchange these two columns, so my answer is negative A. So this is how you want to deduce the value of the determinant by interchanging the rows and multiplying something. Okay. And then we have the last over here is the inverse of a matrix. Okay, A multiplied B and B is multiplied A and is an identity. So means over here first thing, there must be a square matrix. Okay, and then after that, over here, if you have A multiplied B and B multiplied A, and then this multiplication equals to identity, so means that B is an inverse of your A, or your A is the inverse of your B. Okay, so they are the inverse to each other. Okay, so now the first thing you need to know, A multiplied with an inverse is identity, or the inverse multiplied the A is identity. So that's why these two are identity for each other. Okay, if your if your inverse exists, A is called invertible or called non-singular. Okay, please, if identity if inverse exists, is called non-singular. If the inverse does not exist, it is called singular. So don't change the name. Okay, and what going to happen? What cause your matrix don't have the it don't have the inverse, means that when your determinant is 0. So how we going to rephrase is, when your determinant is 0, your inverse does not exist and it is called singular. Or when we say a matrix is a singular matrix, means that your determinant must be 0. Okay, and one more thing, that is, we write our inverse as A minus 1. Please don't treat them as an don't treat it as a indices. Bring the A going down. No, this one is not equals to A over 1 over A. Okay, and then, so how to find the inverse of a 2 times 2 matrix? So it is very easy. First thing, you need to find your determinant, AD minus BC. After that, change these two positions, D and C change these two positions, and then put the minus here, and then 1 over. And actually, this formula is forming using adjoint matrix. Okay, so now we look at the former what is called adjoint matrix. Okay, let's say you have an A, B, C, D, E, F, G, H, I. So first thing we need to find is our minor. After that, we have our cofactor. Okay, so the difference between the minor and the cofactor is the sign only. So minus minus. Okay, sorry, this one should be minus. Okay, after that, then adjoint matrix is obtained by transposing cofactor. So means now you're going to have this one. So you're going to transpose this one. Okay, so this one is minus. And then you, after that, you're using this thing. Okay, you are using this one. So now we look at the first one example again, like just we already see it in the previous one. This is how you find your minor, and then you get your cofactor. After that, we get the we're going to that one is adjoint. So how we want to get in our cofactor? So we are transporting. Okay, so if you notice here, okay, so this is my minor, this one is my cofactor, and then how am I to get my determinant? Okay, just now we already look at it, and now the inverse is we transpose this thing. Okay, so how to transpose? 14, 28, this 28 is here, negative 18 is here, so this one is called transpose thing. Okay, then after transpose, this one is already disappeared. Whether you want to multiply 16 inside your matrix or not is individual. Okay, but definitely most of the book they multiply in. Okay, but sometimes I didn't multiply in because it looked very messy. Okay, so then we will in the class we will look at the how to find the inverse for the following matrix and solve each equation or state there is no unique solution. So means that is, if you look at it, this is a matrix, multiply another matrix equals to this one. Okay, so this is 2 times 2. This one is 2 times 1. So you already can expect your A cannot be 2 times 1. 2 times 2. Because if 2 times 2 means your output is 2 times 2. So your A most probably actually is 2 times 1. Okay, so then you will get this one. Or we use back what we learned just now. A multiplied A inverse actually is identity. So if I want to find the value of this one, actually I can use A. I name this one as my B, this one is a C. So I have a BA multiplied C. So actually my A is using inverse multiplied B. B inverse multiplied with my C. This one is giving me identity. B minus C. So identity multiplied any matrix will give me the original matrix. So what is my B inverse? So actually is 1 over, okay, the determinant of my B, and then I have my 6 minus 1 minus 4 plus 3. And then multiply with my negative 16, negative 12. Okay, so what is B? So it's okay, negative 6 minus plus 12. And then this one is 1 over 6. 6 multiplied negative 16 plus 4 multiplied with 12. And then 3 multiplied with negative 16 plus with negative 1 multiplied with negative 12. And then you use the calculator and then you find the answer for your A. Okay, so this one also will be the same. Okay, so this one we will discuss. Okay, so okay. So the previous exercise all I will discuss during in the class. So see you in another video.